Mesh and nodal analysis. The mesh and nodal analysis are two important techniques used in network analysis to find out different branch currents and node voltages. The suitability of each analysis mainly depending on the number of sources present in a given circuit. If in any given circuit, if more number of voltage sources are there, means it is suitable for the mesh analysis. If more number of current sources are there, means it is suitable for the nodal analysis. So first we will see about the mesh analysis. The mesh analysis is used to find the loop currents in the meshes. So to write the loop currents in terms of voltages, the equation is V is equal to I into R. That is, the total voltage gain in the loop is equal to total drop in the loop. So this mesh analysis is combination of KVL plus Ohm's law. And steps to analyze the mesh analysis. So to analyze the mesh analysis, the first step is to identify the number of meshes in a given circuit. And the second one is assign the mesh currents. So to assign the mesh currents, we have to take either clockwise direction or anti-clockwise direction, or we can use both the directions. But if you use both the direction, means you will get confused. So to avoid that confusion, take any one direction. Either it may be clockwise or it may be anti-clockwise direction. So here I am using the clockwise direction. And the third step is develop the KVL equation for each mesh. And the fourth one is solve the KVL equations to find the mesh currents. So these are the 4 steps to analyze a mesh analysis. And the example for the mesh analysis is this. So here 2 voltage sources are there and 3 resistors. So first we have to identify the meshes. So in the given circuit, we have the 2 meshes. The next step is assign the mesh current. So here I am taking the clockwise direction. So this is I1 for the first mesh and I2 current is for the second mesh. Next, the third step is apply KVL for the each mesh. So now I am writing the KVL for the first mesh. So that is, see, first we have to write the sources. So in the first mesh, we have the source is V1. So for this V1, the current is flowing from negative to positive. So I am taking this as plus V1 equal to, then drops are I1 into R1 plus I1 minus I2 into R3. See here, across this R3 resistor, this I1 current is flowing and I2 current is also flowing. But here I am writing the equation for the first mesh. So I have to take I1 as preference. So we will get the equation is V1 equal to I1 R1 plus I1 minus I2 into R3. So that is, let it be equation 1. Next, similarly, apply the KVL for the second mesh. So in the second mesh, the source is V2. So for this source, current is flowing from positive to negative. So here minus V2 equal to, drops are I2 R2 plus I2 minus I1 into R3. Let it be equation 2. Next, solve these two equations. We will get the currents I1 and I2. Let's see example on for the mesh analysis. So this is the example for the mesh analysis, and in this question is asking to find the current through 8 ohm resistor. So to analyze the mesh analysis, the first step is we have to identify the meshes. So in this given circuit, we have the 2 meshes, and second step, assign the mesh current. So this I1 is the first mesh current and I2 is the second loop current. Next, the third step is develop the KVL equations for the each mesh. So for the first loop, the equation is 10 equal to 8I1 plus 7I1 minus I2. So 8I1 plus 7I1 minus 7I2 equals to 10. So 15I1 minus 7I2 equal to 10. Let it be equation 1. Similarly, apply the KVL for the second loop. So here the source is 5 volts and current is flowing from positive to negative. So that is minus 5 equal to 6I2 plus 7I2 minus I1. So that is minus 7I1 plus 13I2 equals to minus 5. Let it be equation 2. So solve equation 1 and 2. We will get I1 is equal to 0.65 amperes. I2 is 0.03 amperes. So in the question is asking to find 8 I across 8 ohm resistor. So across 8 ohm resistor, the current I1 is flowing. So the current across 8 ohm resistor is equal to I1 equal to 0.65 amperes. So this is about the mesh analysis. Next, we will see about nodal analysis. So in the nodal analysis is used to find the node voltages in the circuit and in terms of the current. So the equation is I is equal to V by R. So the total current entering into a node is equal to the total current leaving from that node. So this nodal analysis is a combination of KCL plus Ohm's law. And the steps to analyze a nodal analysis. So to solve the nodal analysis, first for a given circuit, we have to identify the number of nodes. The first step is identify the number of nodes, and after that assign the voltage at each node and one node take as a reference. And the third step is develop KCL equation at each node, and the fourth step is solve that equation. We will get the node voltages. So here, see in this example, the voltage sources are V1 and V2, and it is from positive to negative and it is from negative to positive. So first the step is, first we have to identify the nodes. So in this circuit, we have the two nodes. This is one node and this is another node. And in two nodes, we have to take one node as a reference node, then that value is 0. And next, the remaining node is this one. So for this node, I am naming the node as Vx. Next, apply the KCL for this node. So Vx minus V1 by R1 plus Vx minus 0 by R3 plus Vx minus V2. So here, the source is negative to positive. So here we get minus of minus V2, that is plus V2 by R2, that equals to 0. So after solving this equation, we will get the voltage value. Let's see the example based on the nodal analysis. See, this is a given circuit. So by using nodal analysis, find current across 5 ohm resistor. This is a question. So the first step is we have to identify the nodes and assign the node voltage. So this is the reference node and this is the node. So across this node, we have to apply the KCL. So that is V minus 50 by 13 plus V minus 0 by 5 plus V minus 10 by 1 equals to 0. So from this equation, 5V minus 10 into 5 plus 13V plus 65 volts minus 650 is equals to 0. So 18 volts, 18V plus 65V minus 900 equals to 0. So V is equal to 10.84 volts. So in the question is asking to find current across 5 ohm resistor. So at this node V minus 0 by 5 equals to current across 5 ohm resistor. So I 5 ohm equal to V by 5, that is equal to 10.84 by 5, that equals to 2.16.